Hello, everyone. My name is Alex Sweetser. We want to thank you all for joining today as we talk about cold starts with AWS Lambda and using autonomous concurrency. We are joined today, myself, I'm Alex Sweetser. I lead customer success and technical alliances here at Sedai. Div, I'll hand it over to you to introduce yourself.
Of course. Hello, everybody. My name is Div Shakar. I'm a solutions architect here at AWS. I'm working with Sedai very closely, and I'm very to be here. I'm based out of Austin, Texas.
Thank you, Div. And hello, everyone. I'm Nikhil Gopinath. I'm the VP of Engineering at Sedai, and I closely work with Div and the AWS team, and we help build some of the Lambda capabilities that we're going to talk about today.
Great. So today we're going to talk through a little bit about the partnership between Sedai and AWS, how this journey started, and quickly jump into cold starts and the solutions for performance challenges. We've seen numerous customers in the market have this issue with cold starts when migrating into AWS Lambda. We want to talk through the history of that, as well as some of the solutions that have been developed to help and combat that from an automation standpoint, as well as a fully autonomous standpoint that Sedai offers. We'll go into a demo of how autonomous works with these cold starts and how Sedai can eliminate up to 99% of those cold starts in different use cases. And then we'll open it up to Q&A at the end. If you have questions throughout, feel free to put them in the chat and I will grab them so that we can answer them at the end of the presentation. A little bit about Sedai and AWS. We started this partnership about 1.5 years ago. Since then, we have begun working very closely with Div on the solutions architecture team, as well as the AWS Lambda product team themselves. We were just part of the release for the new extensions API that the AWS Lambda team released a few weeks ago. And we're also an ISV Accelerate partner with AWS. To go a little bit deeper on the AWS side, I'll pass it over to Div.
Sure. Thanks, Alex. Well, my and Sedai's journey, we started working together, I think, this year in January. And together, what we're really focused on was building a go-to-market strategy that focused on building new products and taking them to market through enablement. So in this short amount, I work with a lot of partners, but in this short amount of time, Sedai has really blown away my mind as they have already built a new integration with the AWS Lambda service team. As Alex is talking about right now, they have attained the Lambda service ready designation, got into ISVA, came out of stealth, they've been GA. They also were named the Gartner Cool Vendor for observability and monitoring. So just always mind-blowing with all the amazing things that the Sedai team does here, and definitely one of my most favorite partners to work with. Anyway, diving into cold starts, let's talk about what cold starts are, and are they a good or a bad thing, first of all, right? I mean, so a cold start is the first request that a new Lambda worker handles. So this particular request can take a longer time to process because the Lambda needs to do things like find a space in the EC2 service fleet to allocate that worker. It needs to then initialize that worker, and then as well as it then needs to do the initialization of your particular function that you're running on Lambda, your module, before it can pass the request to your handler. So the first request can typically mean that this can take much longer to execute, and only when the container is up and ready, your Lambda can start running. So it's not a good thing. It's not. It's been a challenge that AWS Lambda users have been facing for the last 8 years. As you can see here on the screen, that 11.4 million Google results show up as soon as you type Lambda cold start. It has been a large pain point for Lambda users, and a lot of attempts have been made to kind of fix it. Warm-up plugins have been around for a while, code changes, increased tolerance, but like, for example, with increased tolerance, you're now taking much more, you're opening yourself up to much more risk because talking about from a cybersecurity perspective, you're opening yourself up to more vulnerabilities there. So this has been a problem. Let's dive a little bit deeper into how the problem has progressed throughout history, and as well as look at some numbers, because AWS and Sedai are very data-driven companies who like to look at numbers. So as you can see on the screen, 13% of total executions of execution durations is consumed by cold starts. 1.2% of all the calls experience cold starts, right, to Lambda. 3 seconds to start a 35 megabyte of Node.js function, which is not good. 3 seconds is like the default timeout time in Lambda anyway. It takes 14 seconds to spin up a .NET environment. So these numbers are not good, as I keep saying. Now let's take a look into some specific companies, as well as a general example, seeing how do these numbers affect things like revenue and other things. So let's take Amazon. For example, Amazon has found out that 100 latency change drives one revenue gain, while Akamai sees that 100 millisecond delay in reducing conversion by 7%. And as well as another research done by Porton found that the sites that load faster than competitors have significantly higher conversion rates. So I think it's clear that performance challenges can lead to missed revenue opportunities. And to look a little bit deeper into that, we'll go on the next slide, where we'll talk about like a general example. So let's take an example of a mid-sized e-commerce startup, which can expect to gain in revenue from improving performance with a 26 millisecond latency reduction. This performance gain translates into an $89,000 a year revenue impact based off of benchmarks. So as you can see, that cold starts are not just like a nice to have UX thing, that the user will get serviced faster. It's also a very huge, it also has a very huge impact on your revenue. So I think it's very important to see all the tools available out there that we can use to fix it. And needless to say, Sedai has a very good one. And to talk more about that, I'm going to pass it over to Nikhil, who's going to go over all the things you can do with Sedai to improve your cold starts.
Great. Thank you, Dave. So I'll briefly jump into a couple of slides ahead and talk about automation versus autonomous, right? So it's critical that we kind of talk about this and understand the different whys. There's some solution that provides you automation, but why is autonomous different, and how does that actually help, right? So when you talk about automation solutions, typically what you do is you understand a problem, you have already validated it, and you know what is the problem, right? So you already are aware of the problem and you want a solution, and you're working towards the solution. So you put the effort to build the solution when it comes to typical automation solutions, right? So what you do as you build the solution is they detect you write something to detect the problem, and then once the problem is identified, you find a way to recommend it, right? So that's the automation that typically people write. Now once that's written, then you still have to figure out, okay, how do I execute this? How do I make this run all the time, right? So those are challenges. That's kind of not what is baked into automation solutions, and that's kind of where autonomous shines, right? It takes the whole the whole problem domain and completely solves it with one single click or with one single solution, right? When you think about autonomous solutions, you think about driverless cars or autopilot in planes, right? It's essentially like with the push of a button, you're disengaging the human part of it and saying, okay, let the system find the problem, let the system validate it, and let the system actually fix the problem as it emerges, or even before it emerges, whenever possible. So that's kind of the subtle nuance between automation and autonomous. And what we talk about here is an autonomous solution for managing concurrency for Lambdas. So let me dive deep a little bit and expand on what Dave mentioned here, right? So this is a basic one-on-one on what's a Lambda and what causes cold starts, and why is concurrency important for cold start, and how do we get about to solve this problem. So I'm assuming a lot of you who are here on this call would be familiar with how Lambdas work. But again, here is a primer, right? So essentially, when you think about a Lambda or a function or a serverless function, you write one piece of logic, one piece of or a function that does something and does something right, probably, right? So you write the code, you write it either with your favorite editor and then push it to AWS, or you use the AWS console to write it. I mean, there's multiple ways in which you can do that. So once it's done and it's published, what happens behind the scene is AWS takes your code, right? So you wrote, let's say, a function in Python or Java, right? It takes your code and builds something like a container, right? It's not exactly, I mean, one-to-one with container, and it's one of the things that Amazon AWS does behind the scene. But for all practical purposes and for rest of this conversation, let's assume it's a container, right? AWS containerizes it. So AWS builds a container out of your function and then stores it in S3, right? So all you've done is wrote something and published it, right? So this is what happens when you do that. Now, what happens when you're ready to actually use your function, right? So let's say you write the function, you deploy it, and now it's waiting for execution. So what AWS does when you get the first invocation is it goes to the AWS S3 or whatever storage where AWS has stored your function container in, right? It pulls it from there and then generates a runtime environment for that. And as a part of that process, if you wrote something in Java, obviously you need a JVM to spin up, right? If it's Python, you need some other environment to be set up and things to be spun up, right? So there is a time delay between the time your request comes in to all the way to actually spinning up all the environment and everything that's needed before your code actually starts executing, right? So that time that's taken before your code starts executing is cold start, right? And this is part of the ecosystem, part of the nature of the way Lambdas and serverless functions in general work. So the first request that comes in experiences a cold start at this point of time and takes a little longer to actually get started on. What happens to the second invocation that comes in? Now, the second call that's coming in, and so the first one has completed execution. And the first invoker has got the results back, right? So now the second invocation comes in, and now AWS knows that there is an environment that's already spun up for it, right? So there's no need to spin up another container and then go to this again, right? So it reuses that container and just passes that invocation to that function, and it just invokes the function and returns back, right? So in this case, there is no cold start, right? So that's the subtle nuance and the difference between a cold started invocation versus an invocation where there is no cold start involved. Now let's expand that, right? Now let's look at this from the point of view of the life cycle of a Lambda, right? So Lambda have a life cycle, and so like I said, the first step in the life cycle of that Lambda container or that runtime is when it's initialized, when it's invoked, right? So the first time it's invoked, you or AWS initializes the runtime and initializes a function as well, right? Again, if your function is in Java and you want to, every time you invoke the function, you are trying to get create a code for the user, let's say, right? But as a part of that process, you may want to talk to a database behind the scene, to MongoDB. You want to set up credentials, set up environment variables, right? These are all things that you would have written in the function again, right? Or warming up some cache, right? So those are the things that happens as a part of the function initialization. And again, that's probably a one-time thing that you want to do for your function. So that's why you are doing it before the actual invocation. And this is another visualization of where the cold start comes in, right? So you set that up. Now the first invocation comes in, like we saw earlier. The invocation goes through. The customer who are invoked this gets the response that they were seeking. And now the container is in memory, right? And it's waiting to serve the next request. So what AWS does here is moves it into a frozen state, right? So your container is there, it's in memory, but it's kind of in a frozen state, waiting for the next invocation. Now, when the next call comes in, it thaws that container, right? It takes it away from that sleep mode, from the frozen mode, and activates it and re-executes it, and which is much quicker than going through that cold start process, right? And this goes on as long as you keep getting invocations, right? So every invocation that keeps coming in will go through this process and get invoked, and the invoker gets the response they were looking for. Now, what happens if there's a longer period of time and there is no invocation, right? So there is a container in memory. It's using up resources at that point, right? So there's some point of time at which AWS decides that, well, I've been holding on this container for so long, right? And there's no one who's going to use it. So so AWS reclaims those resources and shuts down that container, right? So this is the end of the process where the container has lived its utility. There's no one invoking that container at this point of time. So AWS shuts it down, right? So typically, and that's around the 7-minute mark, right? So if there's no invocation for a Lambda for around 7 minutes, AWS cleans up that container and shuts it down. So what happens after that is the next invocation that comes in starts from the beginning, right? So it goes through the entire process of cold start and only then goes through the invocation phase. So that's the initial part of the life cycle of how a single invocation or a sequence of invocations, right? So in this conversation so far, all the invocations came one after the other. Now let's look at concurrency here, right? And why does concurrency matter? And why is concurrency so important? Why do we talk about concurrency when we talk about cold starts? So let's walk through a few scenarios and try to understand the relevance of concurrency when it comes to cold start. So like I said, let's say we have an invocation coming in. It's the first invocation. So we already saw that it will go through the cold start process, right? The runtime initialization and the function initialization. So let's call it just the init part of it. And then we go into the execution part, right? So this is where the actual functions are executed. We understand this now. And you get a second invocation, okay, pretty good. It goes to the same container. You get a third execution, it goes to the same container. Now, let's make it a little bit more sophisticated, right? What happens if a fourth invocation comes in and before the third invocation ended, right? So this invocation is in before a container is now available for it. So in this case, what AWS does, it spins up another runtime, another container for you, right? And this container now goes to the exact same cold start process, right? It goes through the initialization process and the function is loaded into memory and then it's executed, right? So this second or this fourth invocation that came in for this Lambda now experiences another cold start. What happened to the fifth one that comes in again at this before the third or the fourth ended up executing? The same story here, right? The third runtime, a new runtime is yet again created by AWS, and again this one goes through the cold start process and then completes execution, right? So here you see the challenge is when you have multiple executions that come in at the same time, which in other words is concurrency, right? In this case, what we see here is the concurrency of invocation, right? This is how your traffic is coming in, is 3 in this case, right? So you need an idea of how much concurrent request you are going to, you are anticipating, you are expecting, and that in a way drives how much cold starts is being experienced by your customers or people who are invoking your Lambdas. In this case, 3 out of 5 executions ended up being cold started, right? And that's not a good experience for customers. And of course, there's many other implications, like they mentioned earlier, about what it means for revenue and customer retention and all of that. So now let's jump ahead and see what is one of the solutions for this, right? One solution for overcoming cold starts is provision concurrency. So how does that work, right? So essentially, with the idea of provision concurrency, you are asking AWS ahead of time, right? That you are expecting a maximum concurrency of 2, let's say in this case, right? I'm setting it to 2 here, and just telling AWS that, you know what, I want 2 containers to be available for a period of time, right? No matter what the traffic is, and no matter how much concurrency request I get in, you're requesting and you're paying AWS a little bit more money to make sure that you have those containers ready for you when you're ready to execute. So you made this request and AWS spins up those 2 runtimes and it initializes it, right? And during that initialization, there is cold start, but the good news is no one is waiting for it, right? AWS is doing it ahead of time before the first request comes in. So now let's go through the same traffic pattern that we saw earlier, right? Now the first invocation comes in, AWS assigns it to a runtime, it executes, everything's fine. Second one comes in, again it executes, no cold start. Third one, again no cold start. What happens when you get the fourth request, right? Like what we saw in the previous case. Now in this case, again, AWS does not have to spin up a new container because you already asked for 2 provision concurrent instances. So at this point, you get one more container spun up by, sorry, the container is already there, right? So the execution goes into that container and it's executed in parallel. Now what happened to the fifth one? Now things start getting interesting, right? So there's no container here that's ready to serve this, and you have someone who's waiting for a request, right? So AWS goes back to the previous way of, okay, let's now spin up a new container. Let's go through the initialization process and then execute it, right? So in this case, this latest invocation now experience cold start. So overall, using provision concurrency, we have reduced cold start. So it went from 3 out of 5 to just 1 out of 5, right? Which is great, right? You have reduced it. But one of the things, there are pitfalls to this too, and there's a lot of planning and other things that we need to do to get to this level, and we'll see that in just a few minutes. Now, how does is there a better way to solve this, right? How do you actually solve this? One of the challenge with using provision concurrency is you need to get to this magic number of 2. If you know your traffic, if you know that you will only get 2 concurrent requests, then you might as well set it as 2, but you are never guaranteed of that, right? So that's one of the challenges. The other challenge is provision concurrency is built a little differently than regular invocations. You're not only paying for the invocations, but you're also paying for to keep those concurrent instances alive, right? You want to keep those concurrent AWS to spin up those instances and consume memory, even if there is no invocation. So those are some of the things that you need to plan and be aware of before using provision concurrency. So how could a potential solution look like? All right, how would you autonomously manage concurrency? How would you manage it so that you won't have cold starts? So this is what we ended up doing, right, with Sedai. What we do is once we start looking at a Lambda, we start initially by analyzing your traffic patterns. We look at your traffic patterns throughout the day, right? There are seasonal variations within a day. There's seasonal variation within hours too, right? And across days of the week. So we factor all of that in and build a concurrency model. And what this model tells me is what is the maximum number of concurrency that I'm anticipating for the next 1 hour. So let's say if the model predicts that for the next 1 hour, I am anticipating a concurrency of 3, Sedai spins up those 3 containers for you. Instead of using provision concurrency and using the provision concurrency, no, Sedai does this for you. Now, how does Sedai do that? We'll see that later in the presentation today. But now, assuming Sedai understands your concurrency requirements and the containers are spin up, let's see how the experience goes. Now, no surprise here, right? So the first invocation comes in, no cold start, right? It goes to the first container here. The second invocation comes in, again goes to the same container. So pretty much similar to provision concurrency so far. The third one, again, no cold start. The fourth one goes to the second runtime. Now, all this is already managed by AWS, right? There's no magic here. The only thing that Sedai has done here behind the scene is making sure you have 3 runtimes available. And the fifth one comes in. Now, again, you don't have to spin up a runtime here because we anticipated you getting 3 concurrent requests, and we have prepared those 3 runtimes for you. So this, in a nutshell, is how an autonomous concurrency solution would work, right? By anticipating your concurrency requirements and then building a model for that using machine learning and data analysis, and letting that drive the concurrency needs. Now, how does Sedai actually bring these containers to life? This is where the second part of the analysis that Sedai does comes into play. So when you use when you use Lambdas without concurrency, without any concurrency planning, you pay a certain price for it. When you use provision concurrency, you pay a higher price upfront because you are anticipating a certain level of usage. But if your provision concurrency usage is pretty high, above 70% or some threshold, then provision concurrency ends up being cheaper for you. But the hard part of that equation is always finding out at what point is provision concurrency better than just keeping up a instance warmed up, right? So that is the second part of the analysis that Sedai does. And Sedai now decides based on multiple factors whether to have provision concurrency set to 1 or 2 or 3 in this case, and how do you utilize that based on predicted traffic analysis and so on, and then decide the number of concurrent runtimes and then plan it for execution, right? So this entire initialization of containers is the key part of this autonomous concurrency management solution here. Now let's see this with an example, right? So in this chart, what we're seeing in the first chart is traffic, right? So this is an engineer traffic. So you can see traffic going up every hour or every 30 minutes and then going down at a steady rate, right? So this is a typical and this simplified traffic where the traffic keeps going up and down. But this is in a way this is harder for a concurrency management system because the kind of the number of concurrent requests that you get is not completely determined by just the traffic, right? There's so many other factors that decides how much concurrent requests are you going to get. And here is our results on the bottom 3 panels with 3 different approaches. And I'll start with the bottom, right? So with default, with no concurrency management, you end up with a certain cost, but you also end up with significant cold starts, right? As you can see, every time traffic starts ramping up, you start experiencing cold start. This is because, let's say at this part of the cycle, traffic has ramped up, and you have a lot of containers that's ready to serve it. But over a period of time, many of these containers starts to shut down, right? Because they're not being used, right? So those containers go away, and there's only a minimum number of containers available when you're at the low point here, right? But then again, traffic starts increasing, right? At this point, again, those containers need to be brought back to life, right? So then those containers start experiencing cold start, and that's the elevated time that you see here, all these spikes that you're seeing here. Now, setting concurrency to, let's say, provision concurrency to 2 in this case, does not solve a lot, right? Yes, you did get rid of a couple of cold starts, but overall, your concurrency requirement was much higher than 2. Now, how do you anticipate that and how do you prepare for that, right? So that's one of the challenges when you just use provision concurrency without any intelligence behind the scene. And that's the problem that autonomous concurrency very gracefully solves here. During the first initial phase, the Sedai learns the behavior of the traffic, understands it, builds a model, and starts with a very simple naive model to begin with, but which gets more complicated and evolves over time as it sees daily seasonality and weekly seasonality and so on. So as this evolves and a model is built, Sedai now anticipates the number of containers it needs to keep alive, right? Again, using that model, it anticipates it and keeps those containers ready and warm and ready to go, right? So that's why after the initial learning phase with autonomous concurrency, you do not see any cold starts here at all. And from a cost point of view, now for this entire few hours when you actually executed this test here, right, you had to pay an additional price for provision concurrency, right? So which is why even though you just have provision concurrency of 2, the cost is a little bit higher, right? But you can imagine this multiplying orders of magnitude more as you have more lambdas and you invoke the traffic changes and increases and you think about broader windows, right? So provision concurrency adds an additional cost to your overall execution. But with autonomous concurrency, you get the benefit of provision concurrency and more, and at pretty much the same price point as you would have without using concurrency. So from this point of view, it's kind of like obvious and no-brainer that you can use autonomous concurrency, which reduces cold starts, manages your concurrency settings, and without any additional cost or with very, very minor additional cost. But let's see what those numbers might look like, right? With provision concurrency, like okay, so without provision concurrency, let's take a baseline of what is typically that we see with different customers and different environments, right? Without provision concurrency, about 15% of our requests are cold started, right? Give and take, it depends on The programming language you're using depends on the traffic, and depends on the usage. But that's a rough order of percentage of the amount of cold start you might see on an average. And let's say for 500 millisecond average and 1 GB as the memory set, and for 100 million invocations, this is what you would see on a monthly basis. So this is the cost that you would potentially see, right, for sustaining that traffic. Now with warm-up plugins, so this is something we haven't talked a lot about, but warm-up plugins is one way to kind of solve the problem of cold start. Now this is where in the previous conversation we had about automation and autonomous comes into play. Warm-up plugin is an automated solution, right? Yes, it can reduce cold starts. It can bring it down from 15% to, let's say, around 8%. And the cost would be, again, somewhat only marginally different, not a lot. But the difference here is now you have to spend engineering resources to set it up, right? And you have to now build a system that actually knows what are your concurrency requirements. How does it change over time? How does it change when your traffic changes? How does your concurrency requirement change when you deploy a new version into production, right? So these are all things that you need to keep up with, because an automated solution doesn't do that. What a warm-up plugin does is you just set it up to say, warm up 5 containers for me, and then it just does that. That doesn't solve the seasonality problem. It doesn't solve the concurrency problem, right? You still are expected to solve that. So one plugin does work. It reduces cold start, but then it's an automated solution and it doesn't take you all the way through. Now, for a typical invocation like this, let's say if you set the provision concurrency to 2 or some number, again, based on traffic, you definitely will see more reduction in cold starts, but then you are also paying a significantly higher percentage price for that, right? There is a cost involved with provision concurrency, and this is one of the things that people kind of are very apprehensive of when we talk about just using provision concurrency. And on top of that, provision concurrency is by provisioning it, it's again an automated solution. It's not autonomous, right? You can get some level of autonomous there, but again, you have to set it up. There is no autonomous solution that can actually set it up for you and get it and run by itself. Now, contrasting that with autonomous concurrency, we can bring down the cold start to about less than 1%, and the marginal price increase is just a handful of dollars, right? So pretty much at the same price point as without provision concurrency, you can get autonomous concurrency executed, and with significantly to reduce cold starts, right? Pretty much no cold starts. Okay, so now let's talk about how does these two solutions compare, right? And what are the other operational challenges and the functional differences between these two approaches? With provision concurrency versus autonomous concurrency, one of the key things you have to remember is provision concurrency only works with version lambdas. If you're not into the practice and design of using version lambdas, and all your lambdas are in the latest versions, you would not be able to take advantage of provision concurrency. So you have to have additional DevOps and planning cycles to make sure your lambda is a version so that you can plan for provision concurrency. With autonomous concurrency, it doesn't matter, because now Sedai actually understands whether a lambda is versioned or not. If it's versioned, we do take advantage of provision concurrency whenever possible. But the version lambdas or the unversioned lambdas, which cannot take advantage of provision concurrency, still work with a warm-up based approach, right? So there are multiple solutions that Sedai employs behind the scene to make sure you have concurrency being managed. From the analysis time, like we mentioned and discussed earlier, for provision concurrency, you need ahead of time planning. You need to determine the number of concurrency that you're anticipating, and you have to set it up. With autonomous concurrency, that's done automatically behind the scene. With auto scaling, you have to set up thresholds. Again, thresholds. The danger with thresholds is you have to make sure they are always valid. What happens when your traffic changes, when new releases comes in, and all those kind of externalities that you need to plan for. And one of the biggest risks with just using provision concurrency as is the potential of cost overrun. You need to have a very good operations process to make sure Persian concurrency isn't eating through your cloud budgets. Versus with an autonomous system that's autonomously managed, and that's what Sedai does behind the scene. Similarly, now comparing and contrasting with a warm-up plugin. With warm-up plugins, that's a decision. If you want to use warm-up plugins, that's a decision you need to do much ahead of time. You need to, during your development process, you have to decide that this Lambda should be ready for warm-up. And then you have to write your code, and you have to change your code to actually accommodate for that, right? It might be as simple as adding an annotation, but that is something you have to plan during development. But with autonomous concurrency, the way Sedai has implemented, there is no, it is in fact a complete afterthought, right? Even if you haven't thought about the issue of cold start or concurrency when building and deploying the Lambda, with a simple click of a button, which I'll show you through, when we walk through the demo, you can enable autonomous concurrency directly. Right, so there is no planning required. There is no code change involved. There is no configuration change involved as well, right? So for warm-up plugin, you have to set up the warm-up invoker and set up configurations and so on. And it also runs on a static frequency as well, right? It's a little harder to get it more dynamic. But again, with autonomous concurrency, Sedai takes care of all that behind the scene. So those are some of the key difference between other options when it comes to concurrency management. Now, how does this work, right? So what does it mean if you are interested in using this? So obviously, it's all you require is to work with Sedai and enable autonomous concurrency for your Lambdas. So what that does behind the scene, right? What does that involve? So step number one is Sedai autonomously understands your Lambda, understands your traffic patterns, concurrency requirements, and so on, and now wraps your Lambda with an extension. So we have an extension that takes care of all the complexities involved with this, and wraps your Lambda code that you wrote with an extension that is deployed as a layer. This extension on the Lambda now takes care of identifying, whether is this a warm-up? When was the last time it was involved? So it collects all those stats and usage metrics and keeps track on how many containers are warmed up, how many are being expired, and does that match with the traffic and so on, right? So the extension takes care of all that grunt work that you need to kind of plan for away from you, and is a single EC deploy. Complementing that is a Lambda that we deploy along with this, right? So there is, for every account, we'll deploy a Sedai Lambda, or we call it the activation Lambda, AV Lambda. So this Lambda is kind of the mothership for all your Lambda operations, right? For all the warm-up operations, let's say, right? So this makes sure the right number of containers are spun up for every kind of Lambda or every function, right? It maintains a global state of concurrency and consolidates all these metrics and makes that central decision, right? And acts on that central decision. And finally, away from all this is the central core of Sedai, right? This is where all the traffic monitoring happens. The machine learning models are built here, and the models are exported, and the data is exported. And the autonomous core also brings out the nice UI where you can set this up, set your Lambdas for concurrency management. You can see nice reports and do all those kind of management once a Lambda is set up for autonomous concurrency. All right, so having talked about all that and having discussed that, let me jump into the demo here and quickly show you how, this in action. All right, so I am just logging into one of my test environments here, and setting up your Lambda for autonomous concurrency is, again, a very simple process. The only thing you need to do, right? So actually, let me take a step back here. So Sedai has already been set up for your account, let's say, right? So that onboarding process for Sedai is you just give access to your AWS ecosystem either through secret keys or by setting up roles, right? So once you are onboarded into Sedai, which is a painless 10 or 15-minute process, Sedai understands your resources, right? So here we have identified all your clusters, all your Lambdas, all your functions, your ecosystem. And based on that, had built a topology and has collected the metrics. Now, once Sedai has identified all that, right? So here is, this is one of the accounts that I'm talking about that I'm going to demo here, right? So this Pied Piper is an account, and we have, let's say, a handful of Lambdas here. And once Sedai has discovered all this, if you want to enable autonomous concurrency, all you need to do here is just go find that Lambda, right? So I'm saying, okay, I want to turn on autonomous concurrency for this Lambda. I set it to optimization and say, I want autonomous concurrency to be set on for this Lambda, right? And while doing that, make sure you also take advantage of provision concurrency whenever possible, and give me recommendations for it. That's it, right? You just save it, and wait for it. Sedai takes your Lambda, wraps it in a layer, deploys the extension, and then builds the machine learning model is also already partially built at this point, right? And takes advantages of all the things that we talked about. And now your Lambda is, for all practical purposes, free of cold starts, right? It's one less thing you need to worry about. So once this is done, all you have to do here is go start looking at the reports and see the metrics being reported. So you'll see once optimization is done, what is the new behavior of the Lambda, what is the number of cold starts, and all those kind of nice reporting is what you end up getting here, right? So from a user point of view, it is this trivial, right? All you have to do is just enable it, turn it on, and let Sedai do the rest. So that's the power of autonomous versus contrasting that with an automation solution. Well, now you have to build models, and you have to look at traffic patterns and keep it up to date. So this is a huge difference between autonomous and an automatic system that we want to kind of talk about here. Anyway, so that is it, right? I mean, that's all you have to do in terms of your demo, right? You just turn on one radio button and save it, and Sedai is ready for autonomous concurrency. Right. So I'll pause here and invite questions. So
Nico, we have one question. How long does the autonomous concurrency need to learn to be effective?
Okay. Yes, so that's a good question. So because it's machine learning and data-driven solution that's actually driving this concurrency behavior, right? The good thing is we can start identifying. So when autonomous concurrency is turned on for a new Lambda, let's say you build something pretty much new, we start monitoring it immediately, and then we can immediately start acting on it, right? Because we see a cold start, we know, okay, this shouldn't have happened, even though we have no data to validate that, and we start managing your concurrency on day one, right? So implicitly, it just, or imperatively, it just starts maintaining certain thresholds or certain values for it, right? Based on thresholds. But once data starts to seep in, let's say an hour and a day, right? So once you start seeing these different patterns emerge, right? And it really depends on your traffic pattern. Do you have daily seasonality, or hourly seasonality, or monthly seasonality, weekly, right? So as soon as that pattern start to emerge, then I can start moving from that approach to let the model decide that for you, right? So over a period of time, it builds upon that. So the short answer is it's autonomous concurrency starts being effective immediately, but it becomes more and more accurate and thorough as it sees the seasonality pattern and whatever that seasonality for your Lambda invocation is.
Great. Thank you, Nickel. Question number 2. Do you manage other things for Lambda autonomously?
Yes. So concurrency management is just one aspect of what we manage for Lambdas. The other thing that we manage extensively is your memory and memory setting and configuration. And I'll briefly walk you through that, right? So let me take another example of an optimization that we did here. Let's say a simple Lambda here, right? So typically when you build a Lambda and deploy it, you need to apart from the concurrency setting, you also need to set up memory, and you need to set up other attributes to it, right? Now, how much memory do you allocate a Lambda, right? That is one of the questions that we autonomously again answer for you. You just deploy it, we look at the traffic pattern, and then we start optimizing that Lambda. So what is the right amount of memory that gives you the best possible performance? Right? So here in this particular case, right, we see that someone has deployed this Lambda with 576 MB, right? Now, as a developer, as someone who works with Lambda, your gut feeling is this might be a little too much, right? What is the right amount? But this is where the other part of Sedai comes in and does the analysis and say that for this particular Lambda, you need to actually bump up your memory to 864 MB, which is approximately 50% increase. And that would bring down your cost because now your resource consumption is low because your Lambdas are now running faster, right? So this is one of the no-brainer things that Sedai can do for you, right? Not only are we making your Lambdas run faster, you can also run it cheaper by just managing memory and the other configuration settings. So that's one of the other things that Sedai does for you. There's a lot of other things too here that Sedai can do. We do something called as release intelligence as well. Right? So Lambdas, one of the good things about Lambdas is you can develop fast, you can deploy as frequently as possible. But how do you manage your releases, and how do you make sure that your releases are all keeping in line with your SLOs, right? So we manage those SLOs for you. We look at your every release and see how does this release compare with the previous release, right? How does uh, did this last change that I made, did it make a material impact on the performance? Did it make it worse, or did it impact on the number of errors that it threw, right? So all those kind of things can be managed again by Sedai, right? So it gives you a score on your release and says, okay, this was a good release, right? You actually improved performance, or this release actually made things slower, or the number of errors went up. So those kind of autonomous monitoring of your releases and resources is again done by Sedai. And again, this all comes with zero configuration. It's right out of the box.
Great. Thanks, Nicole. Does this include reserved concurrency as well?
Yes. So the autonomous concurrency part that I just spoke about or have been presenting mostly considers reserve concurrency behind the scene, right? But we don't tweak reserve concurrency when we are managing the performance and the cold start part of the problem. Where reserve concurrency actually starts becoming a problem for you is when your concurrency goes up beyond a certain point and it hits the resolve concurrency threshold. At that point, your request starts being throttled, right? So if you have turned on autonomous management, so it actually is a harder problem, worse problem, right? It's not only slowing things down, it's actually outright rejecting your customer's request, right? So it's an availability problem. It's not just an optimization problem anymore. So if you turned on Sedai for autonomous availability, at that point, Sedai says, okay, well, your reserve concurrency limits are too low. Let me set it up for this Lambda and eliminate that throttle. So yes, Sedai treats reserve concurrency as a knob that you tweak when you have availability issues, especially with throttling. So we do manage that as well.
Great. Is there an option to configure via CloudFormation or serverless frameworks?
Yes and no, right? So so right now, onboarding on Sedai and setting up Sedai where we can actually see your resources and all that, yes, you can do it through CloudFormation templates and other ways of onboarding onto Sedai. But managing concurrency right now, you have to use Sedai to do that. But we do have it in the works where you can eventually add a plugin into your serverless configuration or your CloudFormation, so that now which essentially means you have enable Sedai for your Lambda, and then Sedai can take care of the rest. That's something on the roadmap we are working on.
Okay. Might be a question here for both of you guys from Sedai and AWS side. But what about security? What guarantees that it will not bring new security issues?
Okay, so I'll try to answer it first, and Dave, please feel free to pitch in. So there's a couple of ways in which we answer that, right? So the first part is organizationally. So we are compliant along multiple certifications, SOC 2 and so on, right? So organizationally, we are set up for security. The second part of this is we deploy this in partnership with Amazon being a Lambda partner, right? So there are some stringent requirements to be able to get there, right? So the extensions are vetted, it's documented, and we have a well-defined release process for managing it, right? And we go through different stages of testing and QA before we make sure it's actually available, right? So that's the second part, and the third part is the extension itself is passive, right? Everything about the solution is passive. All it does is collecting metrics and then acting on it. And one of the good things about the things that we act on is not disrupting anything that's already executing and running, right? So all we're doing here is changing your settings to increase your memory or your configuration settings, right? So none of them have a direct bearing on security. And the way this works is it's not injecting anything beyond the initial extension that's already vetted. So that's part of the answer, I guess. Dave, if you have any other thoughts on answering that.
I mean, no, not really. I would just like to echo what you said. There are stringent requirements in place that Sedai has not just met, but passed with flying colors. And I think, um, again, like it depends on what you talk about security. You said it's all passive, so there's a low threshold for security that's needed anyway. So no, but I have confidence. We have architected a solution in a way that is secure. I would like to draw your attention though to this important question here. You mentioned, the question says, you mentioned Sedai will go through the Lambda code to fine tune. Does that mean my Lambda code gets uploaded to Sedai environment? So Nikhil, if you wouldn't mind.
Oh, sure.
That's
Getting to that question, yes. So Sedai does not fine tune your code. We don't see your code, right? As far as we are concerned, Sedai, your code and whatever you deployed is a complete black box, right? All we have is an extension that runs parallel to your code, and it's just listening for events. It says, okay, well, here is the function that you wrote, right, which does A, B, and C. We have no insight into what that is, right? All we do is, okay, when is this function invoked? Is it being cold started? When does it end, right? So those are all metrics around the execution of that Lambda that we're looking. There is no introspection of the code. There is no analysis of the code or any of those things that we do, and we don't even change it, right? So this process of adding a layer is an AWS standard way of doing it, right? We have a layer that with the extension that we build, we send it to AWS and say, okay, now add this to the Lambda. Right. So we don't pull your code into our environment or do anything like that. We just push the extension into AWS and say, okay, please do wrap this customer's code or this particular function with this extension, and so that it can collect the metrics and act on it. So that's pretty much how it is. So there's no code fine tuning, or we don't get to see anything that you have actually built.
Yeah, exactly. And this was kind of important. So I'm sorry I jumped the gun there, Alex. But yeah, please feel free to resume questions.
Yeah, no worries at all. Is this still beneficial if we use the new AWS Snapstart feature?
Very timely question indeed. So yes, so Snapstart is definitely a good step and in the right direction to solve cold start, right? What Snapstart essentially does right now is for Java, it reduces the amount of time spending in cold start, right? So instead of, when I spoke about you need to fetch the container from AWS, spin up the Java runtime and all that, right? So AWS takes a snapshot of that, freezes it, encrypts it, and then uses that repeatedly to do that, right? So that definitely improves your or reduces the time that you spend in cold start, but it does not eliminate it altogether, right? So it definitely the biggest part of cold start when it comes to Java is the JVM startup itself. That is the part that is being reduced, but not completely eliminated. So you would still see a little bit of time spent in cold start, but which is probably in line with what you would see with interpreted languages like Python or Node. But you would still see that to some extent it's Snapstart. So so autonomous concurrency will work hand in hand with Snapstart and make sure that we can actually eliminate it, not just reduce it. So it's kind of like both of them can work together.
Correct.
All right, I've got another question here. Let me just put it into the chat. Do you work on any other AWS services like ECS or EKS?
Yes, absolutely. So the focus of this presentation was solely on AWS Lambdas and concurrency. But yes, Sedai does autonomous management of a lot of these things that I talked about for ECS as well as EKS. In fact, and in Kubernetes in general as well, right? With ECS and EKS, we do things like optimizing for your workloads, optimizing your nodes, for optimizing for cost as well as performance, right? So we analyze your ECS cluster, for instance, and say, okay, well, here is a lot of workload that's over provisioned and that needs to be optimized, right? So again, it runs it on a continuously basis. and gives you recommendations. And if you are comfortable with it, we can even execute them autonomously. And same with EKS as well, right? We optimize your workload and make it run in the best possible manner of optimizing cost versus performance. We take that one level deeper and we can do pretty much the same for your nodes as well, right? What is the right sizing of your nodes that will run your entire cluster in the most optimized manner. We could also even give you pricing recommendations based on spot instances versus reserved instances and pricing plan and so on as well.
Great. Thanks, Nickel. And how do you handle autonomous actions if I have scheduled downtime or testing?
Okay, so multiple ways in which we could handle that. If your downtimes are scheduled on a regular basis, like if let's say you always have a scheduled downtime on maintenance every Friday midnight, that's a learned behavior. Said I will autonomously learn that, okay, that's your downtime. We need to scale it down, right? So that's option number one. Option number two is you can come within the Sedai console. You can say, well, this is my testing window, so let me just pause all recommendations or pause all operations, right? So whatever you do in the next 2 hours or until I tell you to, don't act, right? So you can kind of like pause Sedai from acting. Like you can think of it just like disengaging from an autopilot on a self-driving car, right? You say, okay, I'm taking control, I'm going to drive it, and once you're done, you take the hands off again. So yes, so that's built into the product.
We do have a couple more minutes here if there's any other questions from the audience. If you want to click into the survey, we are raffling off a Lego set just in time for Christmas here.
All right. Looks like we're good with questions.
Great. So next steps here for everyone on this call. If you want to try Sedai for free, you can go to our website and actually deploy this yourself in under 10 minutes. And if you run autonomous concurrency for 2 weeks, you'll be entered into a chance to win $1,000 AWS credit. So you can follow that link there, sedai.io/signup. Alternatively, if you want to speak with any member of the sales or customer success, or even Nickel and engineering about Sedai, you can book a one-on-one with us and schedule a call at sedai.io/demo. We'll send you a swag pack once you book that demo and attend as well.
Yeah, and I'll just highly encourage everybody to do that. We at AWS plus Sedai have great things, planned in the future, and we're going to hopefully revolutionize the space.
Well, thank you everyone for joining, and we'll see you on the next one.
Thank you, Aaron.
Thanks, everybody.